Hey guys, I am going to be explaining today the standard algorithm for subtraction and why you do what you do in the problem and why you're allowed to do what you do in the problem. I am going to walk you through it the best I can and explain the best I can. Before I start though, when you're doing a subtraction or an addition algorithm problem, you always want to start from right to left, because if you were to start left to right and you had to borrow going to the right, you'd have to go back again, because when you borrow, you have to borrow from the next highest placeholder, so it would just kind of make you have to go backwards and forward, and it's just easier and smoother if you start right to left and work that way. So, to start out, we're going to start on this side, and we're going to start with the ones, and for this first problem, it is 2 take away 4, and we know that we can't take 2 away from 4 unless we get a negative number, and for this case we want to stay with positive numbers, so we're going to have to borrow. So when we borrow, we're going to go to this next placeholder, which is the tens place. We're going to cross this out and put a 5, and we're borrowing 10 since it's in the tens placeholder. We're borrowing 10 from there and moving the 1 of the 10 over here, making it 12. 10 plus 2, 12. So then we're taking 12 take away 4, which gives us 8. Then we're moving over to the 10 spot, and here the problem is 5 take away 8. We know that we, again, can't do that unless we get a negative number, so we're going to have to borrow again from the hundreds place. So here, we're going to cross out the 5 and put a 4. We're borrowing 100, so we're moving that 100 over to the tens place, putting a 1 in front of the 5. So here we're borrowing that 100 and adding it to the 50 that was already there because of where its placeholder is at. It was 60, crossed it out, made it 50 after we borrowed. So now this is representing 150, but for this problem you can just look at these numbers and I'll explain later. But for right now, just know it is 15 take away 8, but it represents a bigger number. So 15 take away 8, which is 7. Then we're going to move over to the hundreds place. This is 4 take away 3. We know we can do that and get a positive number, so 4 take away 3 is 1, and our answer is 178. I am going to show it in a different form so that I can explain a little bit further why you are able to borrow from each placeholder and why you're able to just look at single numbers in these and not it as a whole, or not thinking 500 minus 300, because we always think 5 minus 3 or 5 take away 3. So I'm going to explain why we're able to do that and why it works for the problem. So if you were to break down these numbers, it would be 500 plus 60 plus 2. And then if you broke down this number, it would be 300 plus 80 plus 4. And we're taking away this number. The reason I put parentheses is so you know that this is still a subtraction problem, but we're just expanding these numbers. So this is still 562 just expanded, and this is still 384 just expanded. So we're just breaking it down from ones, tens, and 100s place. So we're going to start on this again, on the ones again. We know 2 take away 4 would give us negative 2, and we want to get a positive number. So we're going to borrow from the 60 like we did before, except here it was a 6, but now you can see that it represents a 60 because it's in that placeholder. So we're going to cross this out and put 50. And over here we're going to put the 1 for 12 because we're borrowing 10. Still makes it 8. We're going to put an addition sign because we know that this is expanded, but when we add it all back together, it will always equal 384. And so if we're working with expanded notation right now and we're subtracting and we're ending in expanded notation, we know that we also need to revert back to a whole number, adding them all back together. So then we're going to move to the 10 spot where it's 50 take away 80, or as you see up here, 5 take away 8. And the reason that we're able to just look at 5 and 8 alone is because 50 minus 80 will still, sorry, I'm getting ahead of myself. Okay, sorry, backtrack. We are going to look at this and it is 50 take away 80. We know we can't do that without getting a negative number, so we're going to borrow again from the hundreds. We're going to cross this out, making it 400 because we're borrowing 100. We're going to move that 100 over to this place like we moved the 10 over to this place, making it 150 because we added 100 to the 50 that was already there. So then, when we take 150 minus 80, we get 70. The reason we are able to just look at 8 and 6, or 5 and 8, or 15 and 8 in this case, is because no matter whether you put the 0 there or not, 150 minus 80 will always give us 70, and 15 minus 8 will always give us 7. So it's still representing 70, but we're just looking at the placeholder of the number that it's going to be at, or the number where the placeholder where the number will reside is what I'm trying to say. So it will always be 7. That's why we are able to disregard, because it is, when it's broken down like this, you can see that these zeros, don't have to worry about them because this will take the place of that, but it's still representing 70. So then we're gonna go over to the hundreds, and it would be 400 take away 300, which would give us 100, or 1 like we saw up here. And in this case, 8 is still 8 single cubes. 7 will always represent, in this case, 7 longs, and this will always represent 1 big cube, essentially. So then, right here, same thing. Even with bigger numbers, 500 minus 300, 60 minus 80, 2 minus 4, after we've carried all over different numbers, it still represents the same number. You just don't need to think of it as the bigger number, because it will still give you the number that you're needing, because those places are still there. Just because there's another number there doesn't mean that it loses its value or it isn't 60 anymore. It's still 60. It just has 2 in the ones place. So here it's 62 or 562. So it's still representing hundreds, tens, and ones. So you're still going to get, after all of this, 178, because you have 100 plus 70 plus 8.